Hi everyone. We are still on statistics, and the topic we have today is measures of location and spread. This is what some books say. Other books, they just say location, and then that will be followed by mean, median, and mode. But what does that mean? Mean, median, and mode, or center of location and spread. What does that mean when you are dealing with data sets? It means you are looking for a summary of where the center of the data lies. Mean, median, and mode. In other words, these are all averages. You are given a certain piece of data. You are asked to find the mean of that data. You are looking for the average. You are asked to find the median of that data. You are still looking for an average of what? You are asking to find the mode of that data. It's still an average, but these are averages that are different in perspective. And the best way to explain these averages is by looking at a problem. Try to solve a problem, and then you will understand what it means to find the mean of the data, or the median of the data set, or the mode. There are other things you can find from a data set. We haven't reached to that level yet, because when you see here measures of location and spread, this spread, you can't be looking at something like the variance and the standard deviation, but we haven't reached to that level yet. So we have one problem here. The problem states the weights of wild mushrooms are collected every day over a week as shown. Every day over a week. So you are given the weights of the mushrooms in grams. So the first day collected 500 grams. The second day collected 700 grams. Third day 400 grams. Followed by 300, 900, and 700 grams. Now the question says, question A, find the mode, mean, and median for this data set. And the B part says, on the next day, 650 grams of wild mushroom was collected. Write down the effects this will have on the mode, the mean, and the median. So let's jump into solving this problem. These problems are usually straightforward, just a matter of using your formula. I don't want to write formulas here. I want us to understand the concept. So the best way to start solving such a problem, because you are asked to find the mode and the median here, if you were only asked to calculate the mean, you could just jump in straight into the problem. You all know what mean is. Finding the mean of a data set, we all know what it is. It's finding the average. Finding the average. But since we are asked to find the mode and the median here, so our best approach is to sort out this data in ascending order. You go to arrange your data set first. You have 500 here, there's 300 here, there's 700, there's 900, 700, you can see it's all over the place. So let's start by arranging our data set. We start with the smallest number, which is 300. I'm gonna discard the gram. I'm just writing the numbers. I'm not going to include the units. So we start with 300, that's we are solving our problem A, followed by 400, followed by 500, followed by no 600, now we have 700, another 700, and then 700 again, and finally 900 here. You have 1, 2, 3, 4, 5, 6, 7 data sets. 1, 2, 3, 4, 5, 6, 7. That is it. It's correct. So you got this. This is your data set. And now you ask to find the mode. As I said earlier on, these are all averages you are looking for, but they have their own interpretation. When you are asked to find the mode in a data set like this, what that means, you are looking for the highest frequency on your data set. So the mode here, that is, you are looking for the data set that occurs most of the time with the highest number. So you can see 300 occurs only one time, 400 one time, 500 one time, 700 3 times, and 900 only one time. So which means your mode here, the most frequent ones in our data set is 700. So your mode is 700 grams. Grams, yeah? Yes, grams. And the next question says find the mean. What is mean? If you are given a number of school children in a classroom, say 10 of them, and you are given their different ages, then they ask you to find the mean. So you know what to do. So now you are given the mean, you're asked to find the mean. So what you do is you sum up everything, and then you divide by the number of the items. In this case, you sum up all these data sets, then you divide by the number of the items. So that's what we're going to do. We'll be adding 300 plus 400 plus 500 plus 700, 700 again, 700 again, plus 900, and then we divide by 1, 2, 3, 4, 5, 6, 7, since there are 7 items we have. So, how do we add? You have 3, 7, 12, 19, 26, 31, 40. Let us use calculator, sometimes makes our life easier. You have 300. I'll just say 3 plus 4 plus 5 plus 7 plus 7 plus 7 plus 9. This is 4200. You have 4200. And how many data sets we have? 1, 2, 3, 4, 5, 6, 7. 7 data sets. So, there's a formula for this one. What have we done here? What we have done is, the mean, we normally express it by x bar, average, x bar. And then we use this Greek notation we call sigma, that is summation of x, and you divide by n. This is the formula. That is, you are adding, these are x's, x1, x2, x3, x4, x5, x6, x7. So you are adding all the x's and you divide them by the number of the data sets. In this case, we have how many x's? 7 x's. So this is going to be now, when we added everything here, it was 4200 divided by 7. This is the mean. So 42 divided by 7, 6. 42 divided by 7, 600, isn't it? This is 600 grams. So your mean is 600 grams. The mode is 700. The mean is 600. Now you are asked to find the median. So what does the median mean? The median means is that data set. It was because of this median we decided to arrange our data sets in an ascending order. Because the median is that data set that sits on the center of your data sets. In other words, this median is that data set that is in the middle of all of this data set we have here. Itself has a formula. Sometimes when you watch certain data sets, you can easily pick it up. But sometimes you need to work it out, especially data sets that have frequencies. You need to use a formula to work it out. Here, you can see our data set is 1, 2, 3, 4, 5, 6, 7. So the middle one is 1, 2, 3, 1, 2, 3 is this one here. Go from here to here, 3, from here to here is 3, so this one here. But when your data is large, very large, you can't just go and pick one data set and say, oh, this is the median. You need a formula to work it out. So the median here is n plus 1 all over 2. That is the position you are calculating, not the data set itself. It's the position of that data set. That is the median. You are not calculating the data set here. You are calculating the position of the data set that sits in the middle of the data set. So here, n 1, 2, 3, 4, 5, 6, 7, which is 7 data points, plus 1 all over 2, this gives you 8 all over 2, so this is 4. So the data set you are looking for sits at position number 4. 1, 2, 3, 4. So it's 700. So the median is 700 grams. Correct? So now let's move on to part B of the question. I would like to leave these numbers here. Yeah, let's leave them here. I'll use this little space because here we are just going to do some small calculation and then explanation. Now they said on the next day, 650 grams of wild mushroom was collected. Write down the effects this will have on the mode, mean, and median. So what they are trying to tell us, 650 grams of mushroom is added to this data set. So it's going to sit around here. is going to sit around here, the 650. It's going to sit between the 500 and 700. So what effect will that have on the mode? If 650 grams is going to be here, is that going to change our mode? The mode is not affected because the mode is the one with the highest frequency. 650 grams is just another data set like 300, 400, or 500. So 700 still has 3 data sets. So which means is this new data set is not going to affect our data set we have. So the mode has no effect. Yeah? Mode, no effect. No effect on data set. So what about the mean? Does it have any effect on the mean? If we add 650 grams now to this data set, would that change the mean? Of course, yes, it will change the mean, because the mean we sum up all these data sets, then we divide by the number of the data set. So now we're going to add, before we have 4200. It was 4200 when we added all this one. So now 4200 plus 650. $650 grams. Then we'll have 5, 8. So we'll have 4,850 grams this time. And then we've added one data set. So instead of dividing by 7, so now this number here, 48550, we're now going to divide this by 8 because the data set is being added to this one we have earlier on. It was 7, now it's 8, so we divide by 8. So if you divide that by 8, 4850 divided by 8, so you get 606.3 grams. 606.3 to 1 decimal point, 1 decimal place, grams. So you can see, before it was, the mean was 600, now 606, so it will affect the mean. The new data set will affect the mean. So what about the median? Will it affect the median? It's going to be here. Now we're going to have 1, 2, 3, 4, 5, 6, 7, 8. 8 data sets this time. Of course, it should affect the median even without working it out, because you will now have 8 plus 1 all over 2, which is 9, all over 2, which is 4.5. So 4.5, which is, if you look at 4.5, 1, 2, 3, 4.5, 700. So the answer is yes, it will affect our median. So that is we have solved everything. We'll look at a second problem. We'll try to solve a second problem, and then you get familiar with this kind of problems. Thank you for watching. Bye-bye.